All right. So an ellipse, like I said, it's kind of like a circle, but it's kind of like we've either squished it one way or the other to come up with this shape that is called an ellipse. Now, the ellipse has a whole lot more pieces to it than the circle does. It still has the center HK, so that's similar there. It still has the center HK, but we have vertices and co-vertices. So notice the vertices are always on the longer axis. So this one is arranged horizontally. So the vertices are, in this case, on the x-axis or on the horizontal axis. This one is more vertical, so the vertices are on the vertical axis. The co-vertices are on the shorter axis. Now we have some numbers. We've got A, B, and C. So A comes from the equation. Okay, A comes from the equation, and that's the distance from the center to either vertex. So this distance, that distance are the same. B comes from the equation, and it's the distance from the center to the co-vertex. C is the distance from the center to what we call the focus. And notice we have two foci, and they are symmetrical there. They are the same distance from the center, and it's on the same axis as the vertex axis, the major axis. There's a formula for it. It is similar to the Pythagorean theorem, but we subtract instead of add. Okay, we subtract instead of add. That is what is on the formula sheet for the final exam. They give you the Pythagorean relationship for the ellipse. They give you c squared equals a squared minus b squared. You just need to know how to use it. Here's what needs to be noted. A is always greater than b. That's how you know which way it should be oriented. So if x is over the bigger number, then this ellipse is going to be wider than it is tall. If y is over the bigger number, it's going to be taller than it is wide. Okay, so that's how you determine your orientation for your ellipse. All right, let's look at the back of that page and let's fill in some of this information. An ellipse, the technical definition of an ellipse is it is a set of points such that the sum of the distances from any point on the ellipse to two fixed points remains constant. These fixed points are called the foci. Okay, the fixed points are called the foci. That's the plural of focus. They're not focuses, they're foci. Okay. And D1 plus D2 remains constant for all points on the ellipse. So let me just pick another random point. Let me pick a point down here. Okay, so if I go from this focus and find that distance, and from this focus and find that distance, obviously those distances are different from the original ones that were on your picture, but the sum of those distances is the same. If I add these two distances, I'll call it d sub 3 and d sub 4 because they're different than the original ones there. But when I add them together, they are the same as the sum of distance 1 plus distance 2. Okay. Now, they're not going to test you on that particular piece of knowledge, but I just want you to at least have heard how an ellipse is created. Okay? If you measure the distance from each focus to a point on the ellipse and add those distances together, it is always the same. It is a constant sum. All right, so the major axis, here's some terminology. The major axis is the longer axis of symmetry. Kind of makes sense. If you saw the difference between major and minor, I think we could use a little bit of common sense to figure out which one's which. So the minor axis is the shorter axis of symmetry. The center is the point at which the major and minor axes intersect. The vertices are the endpoints of the major axis. The co-vertices are the endpoints of the minor axis. So this is labeled on the front of the paper, but let's put it on this picture as well just to re-emphasize. Let's label these points here. For a horizontal ellipse, in this case, the way that this one is oriented, the x-axis is the major axis. The y-axis would be the minor axis because it's shorter. So where those two axes intersect is the center. So here's the center, HK, or in this case, it's the origin. The vertices are on the major axis. So here's one vertex, here's the other vertex, and they are equidistant from the center. Okay, they are equidistant from the center. So you may have to use that kind of idea. If they give you the two vertices, then the center is right in the middle of it. Same thing if they give you the co-vertices. Okay, the center is still right in the middle of those. That should not be plural down there. That should just be vertex. Okay, and the only points that I have not labeled yet are my foci. So there's one focus, there's the other focus. Notice they're inside of the ellipse, and they will always be inside of the ellipse. Really quickly, let's do it for the vertical one. So the major axis this time is the y-axis. The minor would be the x-axis. Of course, we have the center. I'm just going to use a C. I'm going to use a V for the vertices, CV for co-vertices, and F for each focus. Now, if we have the equation, then we can figure out where all these pieces are supposed to be. The vertices are plus and minus A units from the center. The co-vertices are plus and minus B units from the center. The length of the major axis would be 2 times A. Because if the vertex is A units from the center, we've got A units here, we've got A units on the other side, so the total length would be A plus A, which is 2A. So the minor axis would be 2B. The foci are plus or minus C units from the center, and we find C by A squared minus B squared. Again, that's given to you on the formula sheet. You just need to know where, what A is, what B is. A is always bigger. I'm going to write that again over here. A is greater than B, always. Okay, A is greater than B. So our standard form, if the center is at the origin, then it would be x squared over A squared plus y squared over B squared is equal to 1. An ellipse is always equal to 1, or it should be. That's for the horizontal. If this were a vertical, then x squared would be over B squared. That's why there are 2 columns here. It's just following from the horizontal up here. Okay? If it's horizontal, then x is over the A. If it's vertical, y is over the A. If our center is somewhere else other than the origin, then just like with the circle, we change the signs. X minus h squared over A squared plus y minus k squared over B squared. And then for the vertical, the A and B just switch places. No, that was a lot of information. Any questions about any of that information? Okay, let's use it. So look at number 5 here. What they're wanting us to do is we need to be able to graph it. So to be able to graph it, we need to be able to identify all these different pieces of information. So we're going to start with that. So let's start with the center. The center is easy. Okay, just like a circle. Okay, it comes from what's being added or subtracted from the x and the y. So is x plus 4. So just like the circle, we change the sign. So it's -4. The y is -2. So I'm going to go ahead and mark that on my picture. -4, -2. That's the center of my ellipse. Now, my vertices. Okay, the y was over the bigger number. So this one's going to be vertical. Okay, vertical. I'm going to go ahead and just make that note since the y was over the bigger number. Get that in my head. So a squared is equal to 36. So that means a is 6. So I go up 6 units from my center, and I go down 6 units from my center. 2, 4, 6. So my vertices have the same x coordinate. I didn't go up high enough. There we go. Okay. They have the same x coordinate as my center. They just have, I add 6 to the y, and I subtract 6 from the y. Okay. I think it's easier to put it on the picture first and then look at what my points are actually going to be. So I just went from the center, I went up 6, I went down 6. So if I go up 6, that puts me at -4, +4. If I go down 6, it puts me at -4, -8. Y'all stop me if I do something that throws you off. All right. For the co-vertices, I wish this was a perfect square. It is not. 20 is not a perfect square, so since I got to graph it, I'm going to use my calculator to take the square root. So that's about, we'll go with about 4.5. So from my center, I'm going to go right 4.5 units. So 1, 2, 3, 4.5. And I'm going to go left. 1, 2, 3, 4. Okay. Now, when I write their equation, though, I'm going to use, I'm going to simplify the square root of 20. Let's see, if we simplify that, that's what, 2 square roots of 5. Pull out the square root of 4, which is 2. So I'm going to do -4 plus 2 square roots of 5. And it has the same y coordinates. I'm going to do plus or minus here. I'm just going to write it this way. -4 plus 2 square roots of 5, -4 minus 2 square roots of 5, but it has the same y coordinate. Now, technically, at this point, I can graph my ellipse because I have my vertices and my co-vertices. They're kind of my boundary points, so I can fill this in. Try not to make it look like a football. It doesn't have pointy ends. More circular than a football. But a lot of times, it's more like an egg. Now, not really important to my graph, but they did ask for this information. They wanted the foci, so I need to calculate the foci. The foci is c units from the center on the major axis. So I got to find c. So c squared is a squared minus b squared. So 36 minus 20, so that's 16. So c is 4. So my foci on the major axis, so vertical, so it has the same x. I'm going to add 4 to my center, and I'm going to subtract 4 from the y coordinate of my center. That's where my foci are going to be. Now, depending on how thin your ellipse is, Sometimes the foci will be closer to the edges of the ellipse. Sometimes it'll be closer to the center. It just depends on, like I said, how thin or how fat the ellipse is. The fatter it is, the closer it'll be to the center. The thinner it is, the closer it's going to be to the vertices. But the foci are always on the major axis, so in this case, it's on the vertical axis. Okay. Let me do one of these. Let me do the last one because you have to complete the square before you can find all those bits and pieces of information. Okay. So let's look at completing the square when it looks like this. So I still need my x's together. I need to, it's not really important that I leave a space right now because I'm going to have to factor out something. And the constant goes to the other side. Okay, so 4x squared minus 32x plus y squared plus 8. That constant's got to go to the other side, so we subtract. Now, completing the square. If you recall, you can't do it when you have a coefficient in front of the x squared or the y squared. You have to factor out that coefficient first. So I have to factor out the 4, but I only take it out of the x's. Okay, I only take it out of the x's. The y's, I don't have that problem. So I can just leave them the way they are. Now I'm going to leave my space for completing the square. All right, to complete the square with the x's, divide 8 by 2, I get 4. Square it, I get 16. Now, because there's this coefficient, I don't add 16 to the other side. I have to multiply it by that coefficient first and then add it to the side. So really, I'm adding 64 to the other side. Okay, anytime there's a coefficient in front, you got to multiply what you completed the square with by that coefficient and add it to the other side. Complete the square for the y's. 8 divided by 2 is 4. Squared is 16. It didn't have coefficient in front, so I just added 16. Any questions that need to be clarified about the completing the square part? All right. Let's finish putting this in standard form. So 4 times x minus 4 squared plus y plus 4 squared is equal to, let's see here, negative 76 plus 64 plus 16 is 4. Okay. Now, an ellipse is always equal to 1. So we go through and we divide by whatever was left over here on the right side. So we were left with 4, so we divide everything by 4. So that gives us x minus 4. Technically, we're not going to write this, but I'm going to put it there anyway so we can get that number over 1 for the x's. There was nothing that simplified for the y's, so that remains over 4, and that's equal to 1. So this is another vertical because y is over the bigger number. Do y'all want me to go through all of these pieces again, or can we take it from there? I feel like nobody wants to speak up and say that we need to do all the pieces again, so I'm going to do that. Center, positive 4, negative 4. Change the signs when we take it out. So go ahead and graph it. Positive 4, negative 4 is our center. The vertices. Okay, the vertices are on the major axis. So a squared is equal to 4. So a is equal to 2. So we go up 2 and down 2 from our center. So they have the same x. They have different y's. So the x stays the same. We add and subtract 2 from the y coordinate of the center. The co-vertices are on the minor axis, so b squared is equal to 1. So b is 1. So we go left 1, right 1. So that changes our x. We're at 3, negative 4, and 5, negative 4. So again, at this point, we could fill in our ellipse. Really hard not to make that one look like football, but it is what it is. All right, last step, foci. C squared is equal to a squared minus b squared. So 4 minus 1, that's 3. So c is the square root of 3. It's on the major axis, so the x stays the same. We add and subtract that from the y. And the foci, the x stays the same because we're on the major axis, so it has the same x coordinate as the center, but the y coordinate is what is different.